Welcome to Study Loop.
There is a 6-phase cycle of gasoline internal combustion engine. So here these 6 path of the cycle is given as path OA is isobaric, where from O to A the pressure remain constant. Path AB from A point to B is as adiabatic. Path B to C is isochoric. Path C to D is adiabatic. Path D to A is isochoric again, and the last one completing the cycle from A to O is isobaric. So we are also given that E is equal to W upon Q1, so take it as equation 1. W is given as Q1 minus Q2, take it as equation 2. Q1 is equal to NCV at constant volume at TC temperature difference minus C to B CV, and Q2, so take it as a equation 3. Q2 is equal to NCV TD minus TA. So this is equation 4. So for part A of the question, we know that the efficiency of a heat engine is given by equation 1 above. So now we will see as E is equal to Q1 minus Q2 upon Q1. So here E will be as E is equal to 1 minus Q2 upon Q1. So simply putting the value of W from 2 into 1, so we get E is equal to Q2 upon Q1, and take it this as equation 5, where now putting the value of Q1 and Q2 from 3 to 4 into equation 5. Now this E would come as 1 minus NCV TD minus TA upon NCV TC minus TV. So E will be as 1 minus TD minus TA upon TC minus TV. So we take it as a part A. Now calculating for the part V, so we are given as VA, the volume at A and volume at D is equal. So take it this relationship at 6, and given that VV is equal to VC, that volume at V point and volume at C point is again same. So this is again 7. Now we know that from second we can say this stroke AV so this is stroke AV is adiabatic and from sixth the stroke of CD as CD is again adiabatic hence for part V we know that the path AB and the CD are adiabatic process so here we can compare as TA VA rho minus 1 is equal to TV VV rho minus 1 so this is equation 9 TC VC rho minus 1 is equal to TD VD rho minus 1 so this is equation 10 now substituting equation 9 from 10 so subtracting equation from 9 from 10 so we will get as TC VC rho minus 1 minus TV VV rho minus 1 is equal to TD VD rho minus 1 minus TA VA rho minus 1. Here we know that VA is equal to VD and VV is equal to VC. So we can here put these values in this equation to make it simplify as TC VV rho minus 1 minus TV VV rho minus 1 is equal to TD VA rho minus 1 minus TA VA rho minus 1. So now simplifying this equation in this order we get as VV rho minus 1 as common factor as TC minus TV will remain here is equal to VA rho minus 1 TD minus TA. So here VV rho minus 1 upon VA rho minus 1 is equal to TD minus TA upon TC minus TV. Now to solving this equation further, in order to get the desired answer we divide numerator and denominator y b rho minus 1. So here we can say that TD minus TA, so this is TA upon TC minus TV is equal to 1 upon V A rho minus 1 upon VV rho minus 1. So here we can further write this equation as Td minus Tc minus Tv is equal to 1 upon Va upon Vv is equal to rho minus 1. Now we know that Va upon Vv is equal to R. So as given in the equation 6, so here we can write this expression as Td minus Ta upon Tc minus Tv is equal to 1 upon R to the power rho minus 1. So this way E would come as E is equal to 1 minus 1 upon R to the power rho minus 1. So this is the relationship of efficiency in terms of rho and R. Now for part C, R is given as 6 whereas rho is given as 1.4. Now putting this value in the above expression, we get simply E is equal to 1 minus 1 upon 6 to the power 1.4 minus 1. So it would come as 1 minus 1 upon 6 to the power 0.4. So this is a 6 to the power 0.4. So simplifying, we get as E is equal to 0.51, or say in terms of percentage, E is 51%. So efficiency of engine would come in this process as 51%. So this is the answer and explanation of this question.